We will now continue with section 1.8, rational and radical equations, and look specifically at simplifying complex rational expressions. Our first example is 1 divided by x plus h minus 1 divided by x, all divided by h. You may find that it is easiest to concentrate on the numerator of this fraction first and try to determine a common denominator. So for our numerator, which is 1 over x plus h minus 1 over x, we're going to use as our new denominator the product of the two denominators. So we're going to use x times x plus h. So we'll keep that in mind as we start to work this problem. So looking at the first fraction, 1 over x plus h, and comparing it to our new denominator, we see that we're going to need an x. So I'm going to multiply the denominator by x, and remember that if you do that, you're also going to want to multiply the numerator by x. Our second fraction, 1 over x, when I compare the x to the new denominator, I see that I need to multiply by x plus h. And again, if I'm going to multiply the bottom by x plus h, I need to multiply the top by x plus h. So we have x over x times x plus h minus x plus h over x times x plus h. So now that we have a common denominator between these two, I'm going to merge them together as one fraction. So I have x minus, I'm going to go ahead and distribute that negative as I do this, x minus h over our new denominator, x times x plus h. You can see now that the x's will cancel. And so the numerator of this fraction will simplify to negative h over x times x plus h. Now, once that step is done, let's go back to our problem and let's look at what we've got. So we know that the top part of the problem, the top of the fraction, negative x, and then x over x plus h on the bottom. And that is all divided by h. Now, keep in mind that this h is over a 1. And we know that technically we're really not going to be able to divide fractions. So instead, we're going to have to multiply by the reciprocal. So I'm going to make a little room down here now that we've done that. And let's see what happens when we multiply by the reciprocal. So we're going to write the numerator down as it is. And then instead of dividing by h over 1, we're going to multiply by 1 over h. And when we do that, the h's will cancel out, leaving me as a final answer negative 1 over x times x plus h. Let's move on to part B. Part B, we have x to the negative 1 minus y to the negative 1 divided by x to the negative 2 minus y to the negative 2. Let's begin by creating some fractions to eliminate these negative exponents. So we know that x to the negative 1 can be written as 1 over x to the first, or just 1 over x. And y to the negative 1 can be written as 1 over y to the first, or 1 over y. X to the negative 2 can be written as 1 over x squared. And y to the negative 2 can be written as 1 over y squared. Now, let's do a common denominator for both the top and the bottom of these fractions. So if I look at the top, my new denominator for the top is going to be x times y. So looking at my first fraction, my denominator is x. I need it to be x times y. So so I'm going to multiply top and bottom by y. Looking at my second fraction, the denominator is y. I need it to be x times y, so I'm going to multiply top and bottom by x. And so the top part here becomes y over xy minus x over xy. We'll merge our two fractions together and get y minus x over xy. Now let's do the same thing on the bottom. Our new denominator for the bottom is going to be the product of the old denominators, so x squared, y squared. When I look at my first fraction, it has an x squared, so I need to multiply by y squared on the top and the bottom. When I look at my second fraction, it has a y squared, but it doesn't have an x squared, so I'll multiply by x squared on the top and the bottom. So I'm going to end up with y squared over x squared times y squared minus x squared over x squared times y squared. And again, merging those fractions together, y squared minus x squared over x squared times y squared. Now again, we know that we can't technically divide fractions, so our rule of thumb is to write the first fraction down, y minus x over xy, and multiply by the reciprocal of the bottom fraction. So x squared over x squared times y squared over y squared minus x squared. Now, let's look at what we really have here. Let's do some simplifying as we go. So y minus x is fine over xy. I'm going to leave that as it is. The x squared, x squared is really x times x, and y squared is y times y. So I'm going to break that out a little bit so I can see it a little bit better. And y squared minus x squared is a difference of two squares. So I can factor that into y minus x and y plus x. And so let's look at what will cancel. One of these x's is going to cancel with one of those x's. One of those y's cancels with one of those y's. The y minus x cancels with the y minus x. And so what are we left with? We have an xy on the top, and we have a y plus x on the bottom. And so that will be our final answer for simplifying this complex rational expression. Now, logically, this leads us into this next example where we're asked to solve the following rational equations. So remember that this means to solve means that we're going to find the x values that make each one a true statement. So let's begin with our first one, which is x cubed plus 3x squared divided by x squared minus 2x minus 15 is equal to 4x plus 5 over x minus 5. Let's begin by doing what we can on the left-hand side to simplify that expression. So if I were to factor the top, I could pull out an x. And if I take an x out of an x cubed, that leaves me x squared. If I take an x out of a 3x squared, that leaves me 3x. And actually, as I'm looking at that, what could I have taken out? I could have actually taken out an x squared, and that would have been a little bit better. So let's fix that. So if I take an x squared out, x squared times x makes x to the third, and x squared times 3 makes 3x to the squared, and that is a little bit better. All right, let's look at the denominator. X squared minus 2x minus 15. We're doing FOIL method in reverse here to get it factored. We know we're going to need x and x. For the factors of 15, we would want to use 5 and 3. We want a negative 2, which means the larger term down here needs to be negative. The other one needs to be positive. So right now, in looking at that, before I go any further, I can say to myself, okay, I see that the x plus 3's are going to cancel out. Now, there's not a lot I can do on the other side. 4x plus 5 and over x minus 5, that's pretty much as simplified as it's going to get. So let's look at what we want to do here. Since we have it set equal to each other, we could cross multiply. And so let's see if that will help us. We could take this x squared and multiply it times the x minus 5. And we could take this 4x plus 5 and multiply it times that x minus 5. And so you notice in doing that you have an x minus 5 on both sides. So that would be an easy term to either factor out and divide out, or just we could come in and we could divide both sides by x minus 5. And so what we really want to be working with here is x squared is equal to 4x plus 5, which I note as being a quadratic equation. And I know that quadratic equations are most typically solved by factoring. So let's go ahead and put everything on one side. I'm going to subtract the 4x first. So I get x squared minus 4x is equal to 5. And then I'll subtract the 5. So x squared minus 4x minus 5 is equal to 0. Let's factor that. It would have to be an x and an x. On the 5, we would do a 5 and a 1. We want the 4 to be negative, so our larger term needs to be negative, and our smaller one needs to be positive. And so our solutions coming out of this, setting each of these factors equal to 0, we would get x is equal to 5, and we would get x is equal to negative 1. However, we know that 5 cannot be a solution, because if we plug 5 in here, we're going to get 0 in the denominator of a fraction. And so you do need to check those. We're going to eliminate that as a solution, and our only solution will be negative 1. All right, and so let's move on then to part B. Part B says that we have 3x squared divided by 5x minus 1 is equal to 0. Okay, so the first thing that we're going to do is we're going to go ahead and move that negative 1 to the other side. So we're going to add 1 to both sides of this expression. So that's going to give me 3x squared over 5x minus 1 is equal to 1. And again, we can use cross multiplication to take care of our fraction, keeping in mind that this 1 is over a 1. When we cross multiply, we get 3x squared. And going the other direction, we get 5x minus 1. And so again, we have a quadratic equation. Let's move everything to one side and see if we can solve it. So I'm going to subtract the 5x off first. So 3x squared minus 5x is equal to negative 1. And then I'm going to add 1 to both sides. Remember that a quadratic equation has to be set equal to 0 before you can try to factor it. So we have 3x squared minus 5x plus 1 is equal to 0. To make the 3x squared, it's going to have to be a 3x and a 1x. To make the 1, it's going to have to be a 1 and a 1. And because we need a negative 5, we will most likely have both of these terms being negative. And again, you want to check. So as you go in and check this, you'll see that that does not boil back to this. And so even though we don't have any other choices for factoring, we see that the way that we have it factored does not work. So what is our next best option if we try to factor something and it doesn't work? Most students prefer quadratic formula. So let's go ahead and see if we can plug it into quadratic formula and get a solution. So remember that your A value is 3, your B value is negative 5, and your C value is 1. So we're going to say x is equal to negative b. So I'm going to do negative 5 plus or minus b squared. So negative 5 squared minus 4 times a times c. All over 2 times a. So 2 times 3. As we simplify it, negative 5 becomes positive 5. Negative 5 squared is 25. 4 times 3 times 1 is 12. 2 times 3 is 6. So we have x is equal to 5 plus or minus the square root of 13 over 6. And these two solutions are solutions to our rational equation.